What's up, YouTube? Today I'm going to be working on this little light here. It's supposed to be like for a display, you know, like it'll have little snowflakes in there or something. But basically what I want to try to do with it is, first thing, I got to get a way to control it, because right now it'll just, you push a button and it goes off for 30 seconds or something, and then it turns itself off. And so what I want to do with it is maybe hook it up to where I can control it, maybe put it on my drums, see if I can get it to be any brighter, maybe take it to gigs, maybe just use it for general shooting lighting, or, you know, just for the fun of it. So here's the little circuit board in there. I tried to just, you know, jump some of the other things. There's no numbers on the chip, so I can't get a schematic for that, but what I'm thinking is I'm just going to meter it right now and see what it's actually sending. It's interesting, there's only 2 wires, so we have batteries here, they go through the circuit, then there's just 2 wires that go into the actual unit, which makes me wonder like what they're doing as far as turning the motor. If the motor and the LEDs are powered on the same power, maybe what I can do is separate them and brighten the LEDs, control how fast the motor turns, stuff like that. I also thought eventually maybe of putting this on like a you know, building another motor for it to where I could actually turn it like this. Maybe even building some little lever system here so that I could turn it this way and this way, make the lights brighter, and have it, you know, chilling on a rack or something near my drums. The first thing I'm going to do is just try to meter and see what kind of amps and volts it's sending through these wires to kind of give me an idea of where I should start. Looks like I got 4.3. I was also thinking too, if I could get, here, let me find that thing. So this is what I pulled out of it, which is just this little snowflakes, right? So this spins in there with it in here, and then it shines snowflake patterns. So what I was thinking of doing was printing out on a piece of paper and making like the name of my band in there, or, you know, maybe like some other different shapes, and just printing it onto paper and then putting that in there instead of this, so it would spin around. Alright, I got my computer out, so we remember it's 4.5 volts, 4 amps, probably 4 milliamps. I don't really know. That's alright, we're moving forward. So here's what I've learned so far. This was like a little mock-up I made. Plug it in there. So that what this actually does is, I had a buddy who wanted to get some LED tail lights for his car, and so I showed him this because they seemed rather expensive for what they do, so I built this and told him he could probably just make his own. The idea behind this would be that, you know, if you were turning, you could program the Arduino to accept your turn signal, you know, so you'd flick the switch in your car and it would do this, or whatever you programmed it to do. But so that's not what we're going to do today. You could make it all on when you hit your brakes, or, you know, all on and go in when you hit your brakes, or whatever. Anyways, so let's build a little setup here. Actually, let's probe this and figure out what we're getting from these LEDs. So you can put multiple LEDs on one resistor. I'm not sure exactly 100% of the math, but I know it works based on I did it here. So let's probe and see what we're getting as far as volts and amps out of this, or if we need a different power supply. Alright, so I went ahead and switched out the Arduino because I couldn't figure out if that other one was working. So anyways, now I've got it on for a long period of time. So I can ground in here and check in here. Okay, so that is 4.5. My meter just wasn't fast enough to get it. So that's perfect amount of volts. Alright, round 2. Apparently I was doing that wrong. This can't be... The multimeter needs to be in line. It can't be connected. So what I've got here is I'm grounding to basically the hot side of the circuit, and I'm touching the resistor. So these two are going in between. You know, like if that was in there, I'd turn the light on. So that means we have to remeasure the other side too when we get it disconnected. So let's see what we get now. So that's 4 milliohms. I'm guessing milliamps. Sorry, that's 4 milliamps. What about through this side? So that's 7 milliamps there. It's probably 8. So that's 8, and then that halves it, I'm guessing. I don't know. We're learning here. You know what I mean? So let's cut this wire. Cut the hot side out of this, which would be, I mean, I guess I could desolder it, but I don't really plan on using any of this, so I'm just gonna cut it. I guess that whole board's just gonna come out anyway. Alright, kinda get it out of there a little bit. Strip it off. So what I'll do is I'll take... Okay, so that's about 8 too. So it looks like one resistor will do it. So let's cut this off. Here. So now we don't need any of that. Strip the negative side. Do the twist job. Negative to ground. Positive to here. And our jumper wire to there. No worky. I don't know if there's not enough power or what. Okay, so this is 8 milliamps running these. Looks like it needs 8 amps to run this big guy. So that means I'm going to have to find a solution for a different power supply than just using the Arduino, which means that I'm going to have to use like maybe a relay or something to power the bigger light. So that's okay. I guess we'll figure that one out on another video. So stay tuned. That's going to be it for this one. Peace.